Hello dear students, myself Alam Sigdar. Welcome back to this channel. Today we are going to start prove that root 2 is irrational. So before prove this, we should know about rational number and irrational number. So rational number, we know which number we can write in the form p by q, where p and q are integers. Where p and q are integers and q should not equal to 0. That means denominator part q should not equal to 0. We know this. So rational number is one. And irrational number, which number we can write in the form p by q. So in rational number, terminating and non-terminating but repeating, and irrational number, non-terminating, non-recurring or not repeating. So we have to prove this root 2 is irrational by the contradiction method. Some problem we can solve by direct method and some problem we can solve by direct method. At that time we have to solve by contradiction method. So in contradiction method, some we have to let or we have to assume to prove that. After assuming that, at the end moment, if we find that our assumption wrong, that means opposite way whatever we have taken, that one is wrong. That means what? Previous one is correct. So in this way we have to solve like this. So something we have to assume and we have to try to prove it, but at the end moment we'll find the result that is wrong, that is our assumption wrong. So this is the contradiction method. So whatever we have to try to prove, anything is true, we have to let it true, but at the moment we find out that it's not true. That means opposite one is false. So like this way, here root 2 is irrational, we have to assume this root 2 is rational. After that, if root 2 is not rational, find out at the end moment, at the time we have to come back. Equal root 2 is not rational means this one is opposite way, we can say irrational. Let it start to prove it. Let us assume that root 2 is rational. Root 2 is rational. Therefore, root 2 is equal to p by q. If rational, then we can write in the form p by q, where p and q are integers. And q prime, q not equal to 0. Q prime means two numbers are q prime when common factors is only 1. At that time, that two numbers are called q prime number. So p and q have no any other factors, common factors other than 1. That means p and q only having one divisors, not other common factors except 1. 1 is the common factors for p and q. After that, root 2 into q is multiplied in divide in right hand side, then it will be multiplied in left hand side is equal to p. Now q is equal to what? P by root 2. We can write root 2 is multiplied with q, then root 2 will be divided in right part. Now squaring both sides, u square p by root 2 whole square. So squaring both sides. Then what we get? Q square is equal to p square by 2. P square by 2. Root 2 whole square means we can write at that time 2. So from here we can write like this: p square is divisible by 2. P square is divisible by 2, or we can write 2 divides p square. P square is divisible by 2, or we can write 2 divides p square. P square is divisible by 2. Therefore, p is also divisible by 2. P square is divisible by 2. This means 2 is a factor of p. According to Theorem 1.3, if p divides a square, then p divides a. According to Theorem 1.3, if p divides a square, then p divides a. This means a square is divisible by p, then a is also divisible by p. So like this way we have to written here: p square is divisible by 2, then p is also divisible by 2. So in this case p square, for we have written this. And now according to q also we have to let it, we have to prove it. Q square is also divisible by 2 and q also divisible by 2. So let it see. Let p is equal to twice a. Squaring both sides, p square is equal to twice a whole square. This means 4a square. So p square is equal to 4a square. We can put it number 2, and this one we can put it number 1. So p square means 4a square, and this value we have to put in equation 1. So from 1 we get at that time q square is equal to p square value is what? P square value is 4a square. So 4a square we have to put here and divided by 2. So 2 in 4 how many times? 2 times. Then q square is equal to 2a square. Here 2 is a factor of q. So q square is divisible by 2. Q square divisible by 2 is equal to a square, where a is some integer. So here also we can write q square is divisible by 2 and q is also divisible by 2. Therefore q square is divisible by 2. Therefore q is also divisible by 2. Q square is divisible by 2. This means 2 divides q square, and q is divisible by 2 means 2 divides q also. So from here we have observed that if divisible by 2 means 2 is a factor. So here for p also having factor 2 and for q also having factor 2. That means p by q they are having at least common factor 2. So we have already proved that we have assumed there P and Q are co-prime, but our assumption is wrong. At the end moment, we have found here 2 is a common factor of P and Q. Therefore, we have taken or we have assumed that root 2 is rational. This assumption is wrong. That means oppositely at that time we can say root 2 is irrational. Not rational means irrational. Therefore P and Q have at least P and Q have at least 2 as a common factor. 2 as a common factor. Therefore P and Q have at least 2 as a common factor, but this contradicts the fact that contradicts the fact that P and Q are co-prime. P and Q are co-prime. That means P and Q have only one common factor, that is 1. But here we have found that root 2 is a common factor. Therefore our assumption is our assumption is incorrect that root 2 is rational. So our assumption is incorrect that root 2 is irrational. Hence therefore root 2 is irrational. Henceforth very simple. First we have to take root 2 is rational. After that we have to solve this by the contradiction method. We have to assume root 2 is rational, and in this case P and Q are co-prime. That is, there have no any other common factor other than 1. But we have found here 2 as a common factors of P and Q. That means our assumption wrong. That's why whatever we have taken here root 2 is rational, that one is wrong. That means root 2 is irrational. Hence proof. Dear students, if you like this video, please follow, share and subscribe it. Wish you all the best.